Welcome to This Explainer. Today, we're diving into something that really isn't just a nice to have. We're talking about clean code, which is honestly an absolute matter of professional survival. In this session, we're going to totally shatter a very persistent and frankly very dangerous myth floating around the software development world. And that's the idea that writing messy code somehow magically makes a developer go faster. Okay, let's just jump right in.
So, let me ask you, have you ever been significantly slowed down by someone else's messy code? Let's be real here. We all have. It's kind of this shared trauma for developers everywhere. Have you ever had to wade through a mess so thick that it took you literally weeks to do what should have taken a few hours? It's like every single time you want to make a simple addition or modification, you have to untangle all these crazy twists and knots just to add more twists and knots. Teams can start off moving at lightning speed, but then eventually they find themselves just crawling at a snail's pace, simply because of the sheer weight of the mess they've accumulated. And why do we do it? Well, we usually tell ourselves a very familiar lie. We say, you know what, we'll just get it working now and we can clean it up later. We just have to get to market first. But then we run face first into LeBlanc's law, which states quite simply, later equals never. That whole excuse of getting it working now and cleaning it up later, it's a total trap. Why? Because those market pressures, they never actually stop. Getting to market first just means you now have a horde of competitors right on your tail, and you've got to keep running. The magical free time to clean up never actually appears. This brings us to what's known as the primal conundrum. Developers constantly feel this intense pressure to make messes just to meet deadlines. But at the exact same time, they know that their previous messes are exactly what's slowing them down. The big lie here is that messy code equals fast delivery in the short term. But the reality, the truth that true professionals understand in their bones, is that making messes is always slower than staying clean. It doesn't even matter what timescale you're looking at. The mess is going to slow you down instantly, and it's going to force you to miss your deadline. The only actual way to go fast is to keep the code as clean as possible at all times. Now, what's really interesting is how we can look at this psychological rot of code through the lens of the broken window theory. Imagine a building with a few broken windows. It looks like nobody really cares, right? So people naturally stop caring. They allow more windows to break, or maybe they even start actively breaking them. Graffiti shows up, garbage collects. Well, guess what? Code works the exact same way. One piece of bad code, one single broken window, tempts everyone else to make it worse. Bad code actually actively tempts the mess to grow. So, how do we stop the decay? First, we need to really understand what clean actually means. Let's look at what you might call a Mount Rushmore of programming wisdom, starting with the inventor of C++ himself, Bjarne Stroustrup. Bjarne says, clean code does one thing well. It is pleasingly graceful. I love that phrase. Think about the word elegant. He wants code to be super straightforward, with minimal dependencies, which basically makes it incredibly hard for bugs to hide. But crucially, he emphasizes that reading your code should actually make you smile, kind of like looking at a well-crafted music box. It is laser-focused on doing a single thing without muddling its core intent. Okay, let's move over to another industry titan, Grady Booch, and see how he builds on this concept by focusing heavily on readability. Grady says, clean code reads like well-written prose. This is such a fantastic comparison. Think back to a really great book you've read. You don't fight the words on the page. The words just sort of disappear, and you instantly see the images and experience the story. Grady's perspective is that code shouldn't ever obscure the designer's intent. It should read clearly, directly, and be full of crisp abstractions. You shouldn't have to struggle to figure out what the code is trying to say to you. And when code reads perfectly like that, it reveals something much deeper about the person who wrote it. Let's see what Michael Feathers has to say about the overarching quality of clean code. He notes, clean code always looks like it was written by someone who cares. Care. That right there is the ultimate defining characteristic of true software craftsmanship. It means the author actually took the time to keep things simple, orderly, and paid serious attention to the little details. When you look at it and try to imagine improvements, you're just left sitting there in appreciation of the incredible effort someone left behind for you. But here's the thing. It is definitely not enough to just write clean code once. You have to maintain it. And this brings us to a highly actionable continuous practice, the Boy Scout rule. Leave the campground cleaner than you found it. Think about it. If we all checked in our code just a little bit cleaner than when we checked it out, the code simply could not rot. It's literally impossible. So what does applying this actually look like on a random Tuesday? It doesn't mean doing these massive, super risky overhauls. It's entirely about tiny, continuous improvements. Change one variable name for the better. Just one. Break up one single function that's grown a little too large. Eliminate one tiny bit of duplication. Clean up a messy if statement. If you do this daily, your software project actually gets better as time passes, rather than slowly degrading into an unmaintainable nightmare. However, I gotta warn you, there is a catch. You absolutely cannot have clean code, and you certainly cannot safely refactor your code without a solid foundation. And tests are that foundation. As the experts firmly assert, code without tests is not clean, period. No matter how elegant or beautiful it looks, if it lacks automated tests, it's unclean. This is exactly where the rigorous cycle of test-driven development, or TDD, comes into play. Tests eliminate the fear that cleaning up the code is going to accidentally break the whole system. Now, if you're sitting there thinking, yeah, but tests just slow me down, take a look at this empirical proof from Jason Gorman's Roman numerals kata experiment. In the data shown here, the green bars represent the days he used the strict discipline of test-driven development, and the blue bars are the days he didn't. Do you notice the trend? Using TDD actually reduced his time to completion. So keeping it clean literally makes you faster, right out of the gate. No debate. To maintain that kind of speed, you have got to watch out for code smells. Here's a rapid-fire list of some of the biggest red flags from John Ousterhout that strongly indicate design problems. We've got shallow modules, where the interface just isn't much simpler than the implementation. Information leakage, where a single design decision is just scattered all over multiple modules. Vague naming that completely fails to convey intent. And, crucially, repetition. The dry principle, don't repeat yourself. Remember, every single time you see duplication, it's a missed opportunity for a solid abstraction. We also need to ruthlessly eliminate bad practices that clutter up our intent. Beware of what we call train wreck code. You know, those super long, highly coupled chains of method calls that force a single function to know way too much. And avoid cuteness, using inside jokes or slang instead of clear terms. Nobody has time to decode your jokes. Instead, rely on clear abstractions. Say exactly what you mean and mean exactly what you say. As we wrap up this explainer, I really want to summarize the core philosophy we've been exploring today. Quality is the result of a million selfless acts of care, not just of any great method that descends from the heavens. Clean code isn't just about high-level, grand architecture or being a genius. It's about everyday workers honoring the simple, everyday actions of their craft. It's about consistent indentation, breaking down functions, writing those tests, and caring deeply about the next person who has to read your code. Which leaves us with a provocative challenge for your own professional integrity. Take a hard look at the code you are writing right now. Are you leaving it cleaner than you found it today? I highly encourage you to take these concepts and apply them immediately. Believe me, your future self and your entire team will thank you for it. Thanks for joining me on this explainer, and I'll catch you next time.